All right, the one that you've all been waiting for. I just know it. Getting Started in Electronics by Forrest Mims. An iconic book in electronics here. Very much one of the first ones oftentimes that people use when they're just starting out in the electronics journey. This is not one that I used or had access to when I was growing up and learning electronics, but I have a copy here because it's just nice to have a copy of this in the lexicon. And he has, I believe, a couple other books having to do with electronics. So let's just get back into this and see what it's all about. On the back, it says it has a little kind of synopsis of what's in the book. So it says we have a complete electronics course in 128 pages. It begins with some basics, static electricity, magnets, solenoids, then basic electronic components, switches, relays, meters, capacitors, transformers, diodes, transistors, and it goes to the integrated circuits, digital integrated circuits, linear integrated circuits, circuit assembly tips, and then 100 electronic circuits. Okay, if there's actually 100 electronic circuits in here, that'll be actually pretty nice to see that and to see what that's all about. So let's get into it. Let's get into it here. Let's look at the table of contents. Here's one thing I like about the book already is that up front it has some symbology here. So you have your logic gates here. You have your photonic components, so basically like photodiodes, photoresistors, transistors, diodes, and then passive components like capacitors and resistors and transformers and what have you. Now, what's kind of cool about this book, we'll see just in a second, you can maybe already tell from like the typeface here, this whole thing is like written as if it was done in like a composition notebook. Okay, so it almost looks as if it was written by hand, this whole book here. And let's see if we can get the publishing date. So 1983. So a lot of people have had a lot of experience with this book, okay? He says this book is for the entertainment and edification of its readers. While reasonable care has been exercised with respect to its accuracy, the author and the Radio Shack assume no responsibility for errors. Okay, so I guess this was made in conjunction with Radio Shack, which is pretty cool. Definitely somewhere where I got a lot of components early on. Wish it was still a thing. All right, so let's look at the table of contents and get started here. So we have electricity. It says putting electricity to work, back to basics, static electricity, current, direct current, alternating current, measuring AC and DC. So that's about the first 20 pages is dedicated to just background on electricity. Then we have electrical components. We go into wires, cables, switches, moving coil meters, capacitors, resistors, coils. That goes on for about 20 pages. And then we have semiconductors. Talks about silicon. And then he goes into diodes, transistors, triacs a little bit. And then that goes on for about 20 pages. So there seems to be a theme here. So he goes about 20 pages on each topic, it looks to be about. Then he goes to photonic semiconductors, which is pretty unique, especially one of these early books in electronics. Usually doesn't cover that much with like photodiodes and all that kind of thing. It's pretty cool. He even has solar cells in here, so pretty cool that he has that. So he has a pretty exhaustive section on that, and it looks to be it goes on for almost close to 20 pages as well. And we have integrated circuits, digital integrated circuits. So just your binary stuff, logic gates and all that. Then we have linear integrated circuits. That only goes on for a couple pages. A very useful material there. Circuit assembly tips. He has temporary circuits, permanent circuits, how to solder, powering electronic circuits. And he has 100 circuits in here. And that's what we're going to take a look at, I think, mostly in depth here to see what we have. If we can just read this off, small signal diodes and rectifiers. So we might have some power supply circuits in here. Zener diode circuits. It'd be interesting to see what he's doing with the Zener diode. Usually that pertains to some kind of power supply. Transistor circuit. Bipolar transistor circuit. Junction FET and MOSFET circuit. So he didn't tell you what the function is. He's just telling you what they're going to use, what they're using in the circuit. So we'll have to go into that. That's going to be on page 100. That's when all the projects start. So we'll go on page 100 pretty soon here after we flip through the first parts of these books and then this book, and then we'll see what happens here. Yeah, so I guess this book was written in conjunction with Radio Shack. So the intention was to really get all your parts, because there's some comments here. So your intention was to get all your parts actually from your local Radio Shack to be able to build most of these circuits in here. All right, and you can see how kind of cool this is. You see, it's not a traditional book in the sense of its type and layout. Like I said, it's kind of like written like in a composition notebook. And you just go through all the notes and follow the paragraphs. And he's got a lot of cool illustrations here all throughout. This is the first part, putting electricity to work. Okay. Next page here is going to talk a little bit about the atom, positive and negative charges. I believe this is going to go into like static electricity. He talks about. Yep, there's static electricity. Then I think it goes into a little bit of magnetism here. Then we have the difference between a conductor and an insulator. Electrical current. Direct current. Even has a little bit of Ohm's law down here. Like I say, this might be out of our scope. I know the gentlemen and possibly some ladies in here too. I don't know. Might be at a certain level of sophistication, I believe, in their electronics journey here. That this book is made more for a younger learner, but it's very cool. Alternating current, electrical circuits. So then he's starting to go into the difference between series and parallel here. So a basic circuit, then you have a series circuit, parallel circuit, series and parallel. Okay, very good illustration of that there. Then we have the same sort. A switch. Now that's a pretty cool representation of a switch. I mean, that really gets you going in terms of really figuring things out. When we think about electronics, we think everything being electrical, but switches are really mechanical devices, right? And it kind of shows that here, just separating a contact, and that's how things flow. He gets into different types of pulses. This is, I think, pretty cool how he has it overlaid here. Rise and fall. Then we have your different types of waves. So a regular AC wave, a DC wave. Can we tell the difference between an AC wave and a DC wave? So the AC wave goes positive, goes positive, and then it goes negative as well. But you see the DC wave only starts from 0 and goes positive, or it could go from 0 and go negative. DC plus a sine wave, and we have an AC square wave, a triangle wave, a ramp wave, and a complex. It's probably like an arbitrary wave, and a voice. Very cool. Kind of gives you a good comparison between different kinds of signal. Oh, then look at the bottom here. Let me see if I can get that on camera here. Look at the bottom here. He talks about noise. He kind of shows you kind of the different components that can be within a waveform, because usually our waveforms aren't necessarily always that pure, right? Unless we're getting it from like a function generator. But you'll have a component of noise, and some of that might even be inherent to your equipment. That's why, maybe the other day in my last video, I talked about how, I've never really had a need for a lot of really overly sophisticated equipment like oscilloscopes and things like that. Well, because for the things that I'm doing, the inherent noise and stuff like that that are inherent to that product haven't really been a detriment to my understanding of my circuitry, right? But a higher quality scopes and all that stuff are going to have less noise, which will then give you more accurate readings, right? Because your noise floor, typically your noise floor is basically how low you can actually read with a certain amount of accuracy. So if you can get your noise floor, if your noise floor is somewhere like around in the milliamps range, then you know that your data at that range is going to not be as accurate. You can't trust it as much. So that's a component of which you always have to take into consideration when you're reading your signal. And he shows it here, how you have to add your noise to your signal, and that'll look like a noisy signal, right? So it's something that usually inherently will travel with your signal. Now, if the noise is not coming from your product, but it's coming from, or not coming from your scope, or it's coming from your actual circuit, and that's something that you can rectify. Okay, electronic components. He has a brief description of wires and cables. Then he has a copper wire gauge diagram here, which is pretty cool. Switches, and he goes into dual throw, single throw, all that kind of stuff. Normally open, normally closed switches. Naturally, after the switch, we have relays and then a reed switch. Reed switch is like just a magnetic switch. Moving coil meter, that we usually just call those analog meters, but that's that. A microphone, speaker, resistors, and has a diagram of how he lays out a resistor, and he has these little, I guess these little electrons, I guess is what they're supposed to be. He has little faces on them, and that's, I guess, how he illustrates the flow of electrons throughout the book. Okay. And he goes into your color code for resistors. Some symbology for your resistors and your potentiometers. Putting resistors in parallel, putting them in series. A little bit of math involved for that. How the capacitor is made. This is page 32. Charging the capacitor. He has a little time graph. I think that's pretty cool that he shows that. Different conversions for microfarad, picofarad. Warning, don't touch a capacitor. Okay, so that's nice that he has that. No, it doesn't want you to get shocked there. Very good. And he has putting capacitors in series and parallel. Capacitors in application, so he has them in a rectifier, smoothing caps we talked about before. And he shows how you can change your signal, basically by filtering your signal and changing the wave that comes out of it through using a capacitor, right? So he shows you there that you had a square wave and then it kind of turned into a sawtooth wave after filtering it with this capacitor. Coils. Gets into a little bit of transformer talk there. Types of coils for radios. Again, more about transformers. A one-to-one transformer, which would be like an isolation transformer. One-to-one transformer, which would be like an isolation transformer. Step-up transformers, step-down transformers. And he has a couple illustrations of an isolation transformer, power conversion, high voltage, got a little, and audio transformer, audio output transformer, MIDI transformers. Okay, a little theory about semiconductors here. A little theory about semiconductors here. Then it goes into the diode. This is page 44, 45. Okay. How diodes are used. He's showing you some rectification with a full wave rectifier. That's something I think we should talk about soon. Now he's going into the junctions. Bipolar junction, NPN, PNP. And look at this. We're getting some. I guess it's pretty cool. So application. Okay, so he's showing a circuit and how you would protect a meter from excessive current using this potentiometer and this resistor. That's cool. Field effect transistors, so it talks about FET transistors, which I'm pretty surprised it gets into this, but that's pretty cool as well. And he should give us some circuits for it. Then he goes into MOSFET transistors, how FETs are used. So he has a MOSFET for a lamp driver. MOSFETs are very commonly used for power applications. Triac, so more power supply stuff. Here he starts going into the photo semiconductors, and he has some illustration of them. He has some illustration of the electromagnetic spectrum, waves and light, optical components, how complex lenses are used. This is some pretty cool stuff. I'm itching though to get to the circuits. Let's see what light detector. So that's all the photo stuff. But let's see what these, okay, gets into a little bit of solar cell stuff. Integrated circuits. Oh, gets into binary, has, looks like a truth table here. Let's see the transistor gates. So it kind of shows you, which I think is important. So it shows you how you do the same thing with a binary gate with regular just semiconductors. Here he has some more on some gates. I'm just trying to get our way through some more digital. Now, let's see if we can get, okay, there's some soldering tips, how to assemble some circuits. Here we get into the 100 circuits, okay, which I think would be the most valuable for anyone that's watching this or wants to partake in, in this book. At the stage that you're at, this would probably be the most important. So the first thing he has is the voltage regulator, and he's doing the voltage regulator by using a string of diodes, which is a primitive way to do it, but it's still a practical way, and it works. This will give you a more consistent voltage if you have, I know sometimes I call it a diode ladder or something like that, or a string of diodes, where that can give you a more consistent voltage. He also has a 9-volt power supply that's using a bridge rectifier and some capacitors there. A voltage doubler, that's pretty cool, but he has that. A voltage doubler circuit, that's pretty interesting. Then another bridge rectifier circuit, a voltage tripler, and then a voltage quadrupler circuit. Okay. Then you have a cascading multiplier, voltage multiplier. This is very much something, this right there, if you can see that there. Cascading voltage multiplier, that's very much something you might see like in a Tesla coil kind of deal. A Zener diode circuit. So that's going to be used in regulation. He's also showing you how the Zener diode can be used for clipping on a waveform. That's pretty cool. Okay, transistor circuits. Let's see what we have here. Moisture meter. That's cool. If you do some gardening, if you've ever thought or curious about that, that's in here. Here's a moisture meter with a relay on it. A metronome. I think this will be pretty cool. Maybe we should do that soon. The metronome, it's cool. It's basically like an oscillator. It's basically like an oscillator circuit. And it'll have a little potentiometer here that you can use for the speed. Now the potentiometer, what that potentiometer do is basically change the charging rate of the capacitor, and that's what changes your time essentially. So it's quite interesting to think of these things. Maybe we'll do a little bit of an analysis of that, because it's kind of interesting to think of these things as, how a mechanical metronome works as opposed to how an electrical one works. The mechanical one works, it's going to work with some gears, and you wind it up, and you basically tilt the needle on it, and the needle has a weight, and that weight can be adjusted through the height of the needle, and depending on where that weight is, it'll make the needle sway for a shorter period of time or a longer period of time, and that'll adjust your speed. here, if we do the same thing electrically, we just basically make an oscillator. An oscillator is basically a circuit that feeds back into itself, and that's where our noise or sound is going to come from. And while it's oscillating, we just have a capacitor here, and we have a potentiometer, and that potentiometer will change the rate of the charge of that capacitor to the point where we could have a metered pulse coming out of it. We have a light flasher. Pretty straightforward. A siren, probably another oscillator kind of circuit here. There's a siren. High voltage power supply. I don't know what he's calling high voltage. Up 220 volts. 220 volts high voltage power supply. I guess this is an inverter. This is from 1.5 volts to 9 volts DC input. You put that through the circuitry, and the circuitry will have a transformer attached to it. Of course, you know, the conversion is only as good as your transformer. It would depend on what the ratio was for your transformer. But yeah, I mean, that would work. That might be something interesting for you guys to look into if you need something like that. Again, as I said with my other video, the best way to start in electronics would be to try to think of things that you might actually need, you know, and not necessarily things that you might need like out in the house or something. That could be possible, but things that you might need in your electronics lab. Like, would it help you to have a DC powered high voltage source, an AC voltage source? Maybe. Okay, here's one I used to do with my students, a touch circuit. Well, there's a touch circuit on a relay. Okay. We have a meter circuit, a timer, an audio mixer. He's got an audio mixer using, looks like a field effect transistor. That'll give us a high impedance input. So we have power, MOSFET circuits to drive a lamp, used for audio signal, so an audio amplifier, MOSFET. You know, MOSFETs, when you think of MOSFETs, you can think of current, you know, usually high current. That's why it's in the audio amplifier for high current. Driving the lamp, high current. On after delay. We have some kind of delay circuit for some reason. I don't know necessarily what the application would be there. Doesn't seem complete. Maybe something that you would use inside of a circuit. All right, page 108, 109. A tone generator, very much like an oscillator, so we still have a bunch of oscillators in here. The organ, I don't know if that, you know, is of interest to anybody, but that's kind of cool because, well, you have basically an oscillator that can make different tones. Okay, so if you see these series of resistors here, and it has a table of the values, you basically have an oscillator here, which then has a variety of different resistors that when you press the button here, we have buttons hooked up to this, or this could be even like keys of like a piano, right? These could be the keys of piano. So when you see like a keyboard, this is kind of what's going on in there. We just have different resistors that are attached to this oscillator, and then when we press the button, that resistor will connect to the oscillator. That will change. This will change the frequency of the oscillator, and you can see here he has a frequency table for all these. So in this circuit, if you're using 100K resistor value, that'll give you about 420 hertz. If you're using a 47K, that'll give you about 1300 hertz, and so on. So that's cool if anybody's interested in like making instruments, basically electronic instruments. Ramp generator, chirp generator, voltage sensitive oscillator. So lots of oscillators in here, which is typical for things like this. There's just some triac circuitry. Those things are just used on power supplies. Usually not that interesting unless you need it, unless you actually need the application of one. There's some photo circuits here. Semiconductor light detector, light deactivated delay or relay, right deactivated relay. So I guess when light is detected, this will turn off. That's kind of a very useful circuit. Like I said, some of these circuits is cool because you could use these out like in gardening, or you can use them out like on your property. You can use them out, you know, to make some kind of switch where, you know, when the sun goes down, something will turn off, or vice versa. Solar battery charger. Oh, light actuated latching circuit. So when there's light, it'll latch, and then when there's no light, it should separate and turn off. Here we have some DC or some digital circuits. So we have a flip-flop here, a clock here, a dual LED flasher, a tone generator. So he's kind of showing you how to do some of the same things just with digital circuits. We have 0 to 9 second or 9 minute timer. Okay. Looks like that might be using something like a decade counter. He's got a touch switch here that he's doing with digital. Another touch switch with digital. Mini radio transmitter that's done digitally, which is kind of interesting there. Another touch switch. A lamp flasher, frequency generator. Random number generator. It's kind of interesting. A sequencer. Railroad crossing flashing light. Okay. Programmable gain operational amplifier. That's interesting. I wonder what that's a 4066. I wonder what that is. That's something I'd look up a data sheet to figure out what that is. Oh, and then he has some of the linear IC stuff. So he has an operational amplifier that's made into an amplifier. So he has an audio amplifier here, a mixer, a difference amplifier, light wave voice transmitter, interesting, a synthesizer, light sensitive up down tone generator. You know, the thing about this is, like, you could take a couple of these circuits and you might be able to actually build something interesting, right? Employ some creativity. Light wave communication receiver will detect voice or tone modulated light beam. Comparator circuit, light level indicator. That's pretty cool. Light level, again, something that you could use probably outdoors if you wanted to meter something. So this will show you the. So what it will do is the buzzer sounds when light falls to level determined by R2. Reverse the connections to pin 2 and 3. The sound tone when the sound will come on when the light increases. So you could use something like this as like a light detector, but this is hooked up to a piezo like buzzer. If you wanted another function, you just take the piezo out and maybe you could hook it up to a relay, or it could turn on another circuit. It doesn't have to be a piezo. You could modify the circuit in that way. Bar graph voltage indicator. Bar graph voltage indicator. This is this here. Let's see what this does. LEDs glow in sequence as input voltage rises. Okay. And then you have some sensitivity controls. Voltage regulator circuit, I think that's pretty self-explanatory there. Variable power supply. This is something that we're going to get into here pretty soon. Remember why I talked about that in my last video about how probably one of the best things for you guys to do if you're really just starting out and you want to be proactive about your learning process and, you know, building something meaningful would be to make something like this. And we'll go over schematic. I'll kind of go through the process of how we're going to do this, but to make a power supply for yourself, I'll do different renditions, but I just really want to show how to make something that would be useful for your projects. Instead of buying a power supply, you could make a 5 volt, maybe a power supply that has a 5 volt fix and has a 30 to 60 volt output on it. And we'll go through that soon and show you how to do that. And there's a lot of different ways to do it, but we'll show you one way or a couple ways to do it. And that could help you guys tremendously on your electronics journey. So we have a basic timer here, a tone bust generator, a pulse generator, LED tone transmitter. Here's a light and dark detector. Again, something that could be used for application using a 555 timer. And he has a speaker on here. Again, we can always change the function. Oh, this is cool. How about an event failure alarm? So So let's say if you could hook this up to a circuit, and if something went wrong with it, this would alarm you, which is pretty cool. Three-stage tone generator, and that's pretty much it. And he has another table on the back of the book for some symbology. I mean, all in all, I think it has some pretty cool circuits in it. That's actually my first time flipping through the whole thing. Like I said, I got it more for a review, more for something just to keep on the shelf as being a part of the lexicon of electronics. But I think some of these circuits are actually pretty cool, and a lot of these things seems to still be, manufactured. Like a lot of these are built on the 555 timer. I saw a lot of those transistors still exist. A lot of those these operational amplifiers still exist. Then it's likely that a lot of these digital devices will still exist as well. So that was Forrest Mims, Getting Started in Electronics. Let me know if you have any questions. Again, very soon we'll start to dial down that power supply project, get you guys started on something that'll be useful in your labs. But that's all it for me today. You guys have a good one. I hope you enjoyed it. I'll see you soon.